All right, recording in progress. So, the world is your oyster. Feel free. I prefer if you say the questions out loud, but if you want to type them in, that's totally fine. Y'all got until 11 o'clock.
Could you explain active transportation, facility diffusion, and passive transport differences?
Yeah, of course. So, passive diffusion, you are going to be, well, all of these are talking about the movement of a substance over the membrane. So, passive diffusion is going to require no transport protein. Things are just going to float across. It's going to be dependent on a concentration gradient. So things are going to want to move from high concentrations to low concentrations. Facilitated transport or diffusion, facilitated in general, is going to be exactly the same in terms of it's going to use a concentration gradient. The difference is that there's kind of a bottleneck because there is a transport protein. So it doesn't just float across the membrane, it needs to go through that transport protein. And then active transport does use a protein. So it still uses that kind of like tunnel or door, but it's not dependent on a concentration gradient. And the reason that it's not dependent is because it has a requirement for ATP or energy. So that energy is actually going to be able to kind of power the pump, so to speak. So similarities, right? So facilitated and passive diffusion are going to rely on that concentration gradient. The difference is the transport protein. Active and facilitated, they both have a transport protein, but active transport doesn't care about the concentration gradient. It can go from high to low, low to high, doesn't really matter.
Thank you.
Mm-hmm. I know sometimes people have to look through their little study guide as well, but if there's anything you're missing on the study guide, that would be a good place to start.
Are you sure how to calculate the percent of each paycal or like how the math formula?
Ah, yes. So it would be really difficult since I don't have like a drawing board or anything like that on Zoom, but and if you need specific examples, you can email me and then I'll give you portions of the question. But it's either going to go from a percentage of each one of the macronutrients with a total calorie amount, or we're going to start at a macronutrient gram amount. So let's say you were trying to figure out the proportion, so like the percentage of carbohydrate in a total diet. Well, you would need the total grams of carbohydrate. Let's say it's 100 grams. You would have to multiply it out to get calories from carbohydrate. So that would be 4 calories per gram. So 400 calories coming from carbohydrate because 100 grams times 4 calories per gram. And then you would have to do that with each of the individual macronutrients if you were creating an entire percentage profile. The opposite I could give you is if I gave you, let's say, like 3,000 calories and it's 50% carbohydrate, 25% protein, and 25% fat, then you would have to know to take that total calorie amount, multiply it by the decimal version of that percentage, right? So 3,000 times 50% would be, 3,000 times 0.50 is 1,500. And then 1,500, let's say that was carbohydrate, divided by four, and then you would get the grams of carbohydrate in that case. So hopefully that makes sense from me saying it. If you want specific examples, I can provide those to you over email, but trying to do it over Zoom would be, I don't have like a whiteboard in here.
Thank you.
Yeah, definitely want to know your conversions, right? So 4 calories per gram for carbohydrate, four for protein, and nine for fat. Do y'all want to know the composition of the exam?
Yes.
So you got about, I want to say it's like 20, it's about 50-ish questions, but it's worth 100 points. So the breakdown is different. Your multiple choice questions are worth two. Your true false are worth one. You have, let's see, You've got like 27, 28 multiple choice. You've got eight or nine true false. You've got a matching section, which is six, seven, it's eight. It's eight things to match. Those are going to be things like think about things that I can word very shortly, right? So an example would be like vitamins A, D, E, and K, you would probably match that up with something, right? Versus B vitamins and vitamin C, you could match up with something else that would be in a similar category. So some basic functions, maybe those calorie amounts that I just mentioned per gram would be something to take account of. Other than that, there are a couple of fill in the blanks. You'll probably remember the fill in the blank from the quiz that we did. I may or may not just take that same question, or maybe what I did is I took that original question that's on this exam and then I changed it a little bit for the quiz. So I wouldn't necessarily like memorize, but are y'all able to actually go back and look at your quizzes or is it closed?
Yeah, I remember yesterday I checked it and then it was still there.
Okay. So I mean that's a decent idea if you can answer those questions and understand why you're answering them the way that you are. That's probably a good idea. Then you have three, technically three short answer. I think I had mentioned that you're going to have to define and describe some reasons why we have food preferences. Things like, financial constraints, location, uh, culture, things like that. But it's not enough to just say the word. You have to be able to describe how, right? So don't just say like, oh, finances influence your eating behaviors. Say finances can influence your eating behaviors because if you are low income, then potentially, you would have to purchase cheaper food, which cheaper food that's more filling tends to be, highly processed. And then other things like I'm going to have a question from your video, no, podcast analysis on red wine. I'm also going to have a question about the Industrial Revolution and what specifically that, what role that played in our current obesity epidemic. Remember, I will answer any question except for what are all the answers to the exam. If you want me to give you
Um,
the answer, I can.
Hi, so question. So for the red wine,
Uh,
in the study guide it says what is the compound that is touted as being most beneficial and why or why not? Like
yeah,
where in the red wine like assignment, what question is that? Because I couldn't find it and I
it's
think I
number
also may have just
four.
done it wrong, but I'm confused.
I'm sure it's number four. I think it actually does ask it what is the specific compound in red wine, and is red wine better for you than other types of alcohol? I can't remember how the question is phrased exactly, but it does ask specifically for that compound, and the compound is called resveratrol, which I just typed into the chat.
Cool, thank you.
Huh? I know you didn't ask, but even though resveratrol is in red wine, you would have to drink an impractical amount of red wine to get an effective dose of resveratrol. And as per the J-shaped curve, if you were to do that, you would not only end up drunk, but you would be probably creating some pretty bad health outcomes with consistent abuse like that. That would be a decent answer to that question if it were on your exam. I already talked about how you're going to have an APA citation question. That one's just going to be I'm going to give you a citation and you're going to tell me what's wrong with it, or maybe there's nothing wrong with it, but it's worth 4 points. So you can take that for what it is. Already said that before in class, though.
For that question, are you gonna be strict with like the italicized parts and stuff, or just like the formatting of it?
Let's just say that I wouldn't pick on like periods and commas, but
Okay,
anything else like the order of things, capitalization,
okay.
italicization, I don't know if that's the word there.
And
Yeah,
now
I
another question on that.
uh,
So on the article review
yeah,
for I think I got part of that wrong because I capitalized like one thing,
uh-huh.
but then I checked the paper they gave me from ethics and it said to only capitalize the first part.
You should capitalize the first letter, but if there's a colon, you capitalize the letter
Does
after that.
Okay, okay, thank you.
Yep. Or proper nouns. That's the other part. So if it's like United States, you would capitalize that.
Another question. Can you review etymology versus RCT?
Yeah. So epidemiology is it's
Oh,
actually
yeah.
called, fine. It's called the study of diseases, or it's known as the study of diseases. And then that doesn't necessarily help you other than understanding that study of disease would be a pretty large population-based thing. So think about epidemiology as like large subject pools, usually like thousands, tens of thousands, hundreds of thousands. And so epidemiology is really good at kind of looking at general trends because when you have that many participants, the precision of the techniques that you can use goes down quite a bit. If I were to draw a parallel, think about like BMI being used to infer weight status in the nation. It's not great because it only takes into account your height and your weight. But doing a DEXA scan or some really sophisticated body composition measure, even doing something like skin fold calipers on each person, if you were trying to collect 100,000 people, would be so time and resource intensive that it's just impractical. So epidemiology as a whole gives us a really good idea of what's happening at a population level, even though it's not generally going to give us a lot of specific, what you would call like causal information, right? Like you're not going to be determining a specific like mechanism of action of a virus through epidemiology. That would be something that you would, gather some, hopefully not, if it's a disease, hopefully not people, but you would be gathering, rats or something of that nature, cells, and actually administering the virus and looking at responses and being able to ask very precise questions. And you could actually infer much better causation. But with epidemiology, we're more so just looking at things like correlations, right? We're looking at broad scoping types of relationships. Does that make sense? Big picture, not very specific epidemiology. Tiny picture, very specific uh, randomized control trial. Lizzie, good? Yeah, yeah.
Sorry, yes, I was eating.
No,
All
you're
good.
good.
Thank you.
Yeah.
You give the definitions for EAR, RDA, and UL.
Yeah. EAR. So there's that figure that I mentioned, I think it was in the first lecture, that has the required nutrient amounts, and it's that big bell curve. And the all of those, they're called DRIs, dietary recommended intakes. They're all basically just trying to give you an idea of how much of a particular nutrient an individual is going to need based on like their age, their biological sex. Like for example, pregnancy is another one that's a separate category that's going to require some different nutrients to be consumed in order to, maintain health to some degree. But EAR is describing the middle of that bell curve. So that literally means the average or 50%. So 50% of all people that would eat, X amount of this nutrient or consume X amount of this nutrient are going to be sufficient. And that doesn't really work. So 50% of the population being like having scurvy is not great for not consuming enough vitamin C. So what they do is they take whatever that 50% number is, and then they multiply it by a given, constant, like a given value that will create like something that's 97% going to cover the population. So that is good enough. 97% is good enough. It's much better than 50%. And the reason that they don't do 100% and just overcompensate is sometimes you get some people that are kind of on the upper end of that bell curve that require so much to be sufficient just for whatever reason. Maybe it's life circumstances, genetics, anything like that. That if you were to overdo that factor, you could potentially start to create situations where you're giving too much, like an unhealthy amount to some people on the opposite end of that bell curve, where you start to get to like the bad stuff starts to happen. That's called your UL or your upper limit. So EAR is 50%, RDA is 97%, UL is like when poops starts hitting the fan kind of amounts in excess. The other one is an AI, which is an adequate intake. It's the same thing as an RDA, but it doesn't have as much evidence behind it for like broad population recommendations. So like sodium has an AI and not an RDA, which may surprise you, but I mean, there isn't a whole lot of research about upper limits of sodium intake for children. Can't really do that. Doesn't mean that we don't know whether sodium in excess amounts is going to be harmful for, development or, risk for cardiovascular disease and hypertension later on. But it is more so just like you can't ethically start cramming that much of a nutrient, and there's not a precedent of data to demonstrate to us where that threshold would be in that particular age range. So hopefully that made sense.
Okay, thank you.
Mm-hmm. Could you hear that over
No.
oh, man.
Um, can you go over the components for energy expenditure?
Oh yeah. So total daily energy expenditure, I'm assuming, in the beginning of chapter 8.5. So that's going to be all
Yeah.
the calories that you burn. And so think of it like a big pie chart. So the big pie chart is going to be all the stuff that you do in a day, whether you think about doing it or not. That is your total calories burned or the total energy that you are going to expend in order to do things. Okay. So your the largest chunk of the pie is going to be taken up by your basal metabolic rate, which is also known as your resting metabolic rate. It's what I called in class your coma calories. So that's everything that it takes in order to keep the lights on. So heart beating and blood vessels constricting and expanding, and lungs is doing all that same stuff, and brain firing off all those electrical impulses, like all of the stuff that you don't actually have to think about. Um, and then you have things on top of that. So you're going to have physical activity, which is making up such a smaller portion. Within physical activity, there's stuff that you try to do. So, like, I'm going to go on a run. That's intentional physical activity or exercise. And then you have something called NEAT, which is non-exercise adaptive thermogenesis. Sometimes you see it activity thermogenesis, but you just say NEAT, NEAT, and that's like all the stuff that you're doing that's physical activity that isn't purposeful exercise. So like walking to class, you don't usually say like, oh, I'm gonna like jog to class for my exercise. It's just how you're getting there. Taking the stairs versus taking an escalator, walking your dog, right? Like all this stuff, gardening. I mean, when I like vacuum and mop the floor, like I'm sweating afterwards. So like it's some pretty intense kind of relatively speaking, it's way more calories burned than if you were just laying down or even sitting down. So and then the last bit is your thermic effective feeding. So that's just going to be the energy that you expend in order to process the food that you consume. That leads into the whole bit in your study guide about the magnitude of effect of the thermic effective feeding within different macronutrients. So, protein has the highest amount of thermic effective feeding, so it produces the most heat because it requires more energy to process that protein. And then carbohydrate would be the next one, and then fat would be the least. Fat is the least. You don't really have to convert fat very much in order to pull energy from it or to create like an excess storage of it. if you were to consume excess calories. Like you don't have to trade all these different things, right? I think about like the situation where the guy takes like a dollar and like trades it for something and it ends up with like a house or something like that. It's a lot more simple than that. Doing that's kind of like what you have to do for protein. You're like trading a dollar for like a Corvette, you know?
Okay, and then also like on the study guides it said relative proportion for each. Do we have to know just like which is most and then like middle and least?
Yeah,
Okay.
I don't like specific numbers
I
unless
didn't think you did, but it also did specifically ask, and I didn't want to assume, like,
yeah, that's why I
cool.
put like relative proportions, right? So
Yeah. So the largest is metabolic, um, and then physical activity is much smaller because then there's the like try and exercise, then meet, and
mm,
then the thermal active feeding, and then
yes,
that's like kind of it.
yep, you got it.
Cool. Thank you.
Yep.
So do the pancreas and gallbladder like release their like the bicarbonate and the enzymes and then the bile into the small intestine, or do
Yeah.
some go in the stomach?
No, none go into the stomach. They release it into the small intestine.
Okay.
So they're now you're making me like go back, which is great to like remember some of the stuff. So there is, I think I've seen some data that shows that the bottom of the stomach does actually have some bicarbonate in it, but I'm pretty sure that doesn't come from the pancreas. But yeah, the bicarbonate that is in the small intestine is made by the pancreas, and it releases it through, exocrine glands into the small intestine to be able to make sure that the acidity that's coming from the all the stuff that was churned up with the hydrochloric acid in your stomach doesn't just start melting away at the area where you're supposed to be starting to absorb things. So, and then the bile is going to be made not by the pancreas, made by the liver, but you do have a reserve of bile, and that's coming from the gallbladder. And the purpose of bile is to make sure that the fat that you have consumed in your diet can mix with the fluid that's inside of your small intestine. And now I have to look up bicarbonate. You can ask questions while I'm doing. No one yet. So it looks like there is some towards the bottom called the antrum of the stomach, but there is so the mucus that's actually formed by the stomach itself on the outer layer actually does have some bicarbonate in it to be able to neutralize contact with the acid. So I did not know that that was true, but it makes sense. So thank you for forcing me to look that up, Keith.
Wait, so but specifically you would just want to say that it goes into the small intestine though, right?
Correct, yeah.
Okay, thank you.
Okay. Can you go over again metabolic reactions to the metabolized macronutrients? I know we literally just did this yesterday, but can you explain it again?
You don't have to say any of that. So uh, I think in
Thanks.
this case, it's really good for you to look at prefixes and suffixes for things. So prefixes would be like, oh, just knowing that lipo means fat. A confusing one would be like glyco versus like glycogeno, right? So glycolysis is the breakdown of glucose, but glycogenolysis is the breakdown of glycogen, and the difference is that glycogen is chains of glucose, it's the storage form of glucose. So the lysis would refer to, lysis means like to cut or to sever. So you know that if you were to see lipolysis, it wouldn't be creating fat, it would be breaking it down or cutting it. Versus if you saw lipogenesis, that would be the creation of fat. So I think like that's mostly what I'm trying to get at with the question is that you can identify it. I think that's probably better to answer your question than just be like, okay, no, anabolic is glycogenesis and lipogenesis and protein synthesis, and no, that catabolic is glycogenolysis and glycolysis and lipolysis. I think it like understanding is what you're, at least that's what I'm trying to get you to do. Understand, recognize. If you ever have to take the GRE, that's what it mostly is. It's not about memorizing things. It's about using your brain to find patterns to rationalize.
Okay, gotcha. Cool. And I'm never gonna take the GRE, so I'm good.
I mean, yeah,
Never say never, but like I'm less likely to. But
it's not
thank
a
you.
hard exam. I do think that it actually has more application in life than like the MCAT for medical doctors, but I mean, I think that it's definitely not something that you like need to take in your life. So
Yeah, and another big scary test I'll probably just avoid. But
yeah,
thank you so much.
life is full of big scary tests.
I know,
And
dude.
fortunately, we can't avoid them forever.
Yeah, but we can pick ones that are like less scary.
But are you always trying to avoid the things that are scariest in your
Oh goodness, now we're getting like methodical.
life? Well, I mean,
No, but
you know what PhD stands for?
um, no, well, like pretty. You invested a lot of time in school. I don't know the acronym actually.
The actual acronym means Doctor of Philosophy. So
Ah,
I sit there and
that's fitting.
philosophize. Philosophy. Wife doesn't like it. That's okay.
Yeah, I know. I was talking to her about well, if anyone has a question, interrupt me because now I'm just yapping. But I was talking to her about, so I did semester at sea, and it was like amazing because you just go learn a whole bunch of things. And she's like, "Yeah, I don't know if I want to do that." I said, "That's fitting. That's valid."
Yeah, I don't
Because
like.
I'm like, you could just like learn forever. How cool. And she's like, "Yeah, no, I really don't like school." And I said, "Yep, okay."
You tell yourself that narrative too. It's like me with the sun. I don't like the sun, and I don't ever want to like the sun, so it's okay. Just like she
Yeah,
doesn't. So that's good.
which I don't understand, but that's okay.
Yeah,
Good for you. More
yeah.
sun for me. No.
Literally do an entire lecture about why